In this lesson, we're going to perform operations on polynomial functions. Operations on functions. So let's say you have two functions. You have f of x equals 7x squared minus 3x plus 10, and you had another function, it's called g of x, and that is 2x squared plus 4x minus 1. Most commonly in algebra, you'll notice when you're given a first function, it's called f of x. If they give you another function, they'll call it g of x. It's always ABC order. If you were given another one, it would be called h of x. Now, there are other variables or alphabets that can be used, but normally they follow in a ABC type order whenever you're introducing more than one function. So with that said, when you see f plus g of x, even though it may look complicated, it is not at all. All they want you to do is to add the f of x function and the g of x function together. And that's just simply adding polynomials, nothing more to it. And if you see f minus g of x, then what they want you to do then is to subtract the function. So it would be this function, f of x, 7x squared minus 3x plus 10, take away the g of x function, which is 2x squared plus 4x minus 1. So it will be this group, take away the second group. And that is what we call operations on functions. Again, it looks more complicated than what it really is. All you're looking for is when you see two different functions, what type of operation does it have in between? Is there a plus between them? Or is there a minus between them? Because that is what's going to determine what you do with those functions. So in this example, we are given three functions, and it started with p of x, and that is why the next function introduced is called q of x. And the next one, because the next letter of the alphabet, would be r of x. And again, it is nothing more than just giving functions an identity so that we know that we're not dealing with the same function. So in the first example, it says p of x plus q of x. So all that means is to take p of x and take q of x and add those two polynomials together. And recall, when you're going to add them together, you need to make sure that you line them up with like terms. Notice here, 4x squared doesn't have anyone to combine with, so we're going to bring it down. So that's going to leave us with the first term of 4x squared. On the next column, signs are different. Subtract, take the sign from the larger number, so that will be bringing down negative 3x. Lastly, combining your numbers, 3 plus 3 is 6. So that's going to leave you with a final answer of 4x squared minus 3x plus 6. The next example, it says q of x minus r of x. So we're going to take q of x, which is 4x squared minus 6x plus 3, take away r of x, which is 5x squared minus 7. Remember, with subtraction, everyone in that second group must be changed to their opposites. Why? Because of this negative effect. Once we do that, we're going to bring down terms that are like each other or line them up. Now it's time to combine. On the first column, signs are different. Subtract, take the sign from the larger number. So we're going to bring down negative x squared. Negative 6x doesn't have anyone to combine with, so we're going to go ahead and bring that down. Lastly, we're going to add our numbers, 3 plus 7. That's going to bring down 10, so the final answer then will be negative x squared minus 6x plus 10. And there you have it, adding and subtracting polynomial functions. Let's evaluate a polynomial function. If f of x equals 2x squared plus 5x plus 7, find f of negative 5. So all we have to do here is to remove the x's and replace them with negative 5 as the input. Do the math and see what we get as our output. So I'm going to go ahead and plug in the negative 5's. When I do so, it's going to look like so. Here we need to do the order of operation, which is the exponents first. Negative 5 squared equals 25. I also want to multiply 5 times negative 5, which is negative 25. Continuing on with the order of operations, multiplication first. 2 times 25 is 50. And 50 minus 25 is 25, and then 25 plus 7 is 32. And there you have it, evaluating a polynomial function.